Before we begin discussing the declaration, it is crucial to understand the importance of what we're talking about. The Large Hadron Collider, LHC, managed by CERN, represents a monumental breakthrough in the field of science. Stretching across 17 miles, this complex system of superconducting magnets is not only the largest but also the most powerful particle accelerator ever built. It stands as evidence of human creativity and the remarkable achievements we've made in the realm of scientific understanding. Remarkably, the LHC is so potent that it can recreate conditions akin to those that existed at the birth of the universe. But as we venture into the vast expanse of the cosmos, we must ask, could this machine, which seeks to discover the most profound aspects of existence, also expose us to unforeseen dangers? Founded in 1954, CERN is one of the most respected research organizations in the world. With 23 member countries and a vast network of researchers, it serves as a major hub for collaboration and groundbreaking discoveries. The LHC, being its flagship project, is only one part of a broad spectrum of particle experiments and accelerators. Consider it a racetrack, not for cars or horses, but for subatomic particles, racing against one another in a high-stakes test of speed, precision, and the very nature of space and time. Within the LHC, protons accelerate to speeds close to that of light, replicating the energy levels present at the moment of the Big Bang. The collisions resulting from this process generate temperatures far greater than those found in the Sun's core. A series of magnets directs the protons on their paths, while sophisticated cooling systems keep the magnets at temperatures lower than those in space. Collisions are deliberately set to occur at 4 separate locations around the accelerator, where specialized detectors, ATLAS, CMS, ALICE, and LHCb, record data. Each detector serves a distinct function, providing different views of the aftermath of these high-energy crashes. Together, they function as gigantic cameras, capturing the effects for scientists to analyze. Researchers sift through the debris to identify elusive particles like the Higgs boson, also known as the God particle, and other phenomena that could shed light on the universe's building blocks. By focusing on the subatomic, scientists hope to gain insight into the very fabric of the cosmos. However, every discovery made at the LHC raises additional concerns. The LHC is more than just a tool for science. It symbolizes humanity's unyielding curiosity and quest for knowledge. It demonstrates our determination to comprehend the forces that control our lives. But as we expand the boundaries of the unknown, we must also face the moral and existential dilemmas that come with it. What risks could emerge from probing too deeply into the unknown? Could our quest for knowledge unleash powers beyond our control? At CERN, where the boundaries of human understanding are stretched to their limits, a troubling realization has come to light, one that has sent shivers down the spines of even the most experienced scientists. Brian Cox, a former CERN researcher and a well-respected figure in particle physics, recently made an unsettling statement that has intrigued and unsettled people worldwide. Cox revealed that the LHC's purpose is to simulate a miniature Big Bang, a small-scale version of the very event that created our universe. He went on to explain the enormous potential of the LHC to uncover groundbreaking discoveries, such as shedding light on the mysteries surrounding dark matter, a substance that makes up a large portion of the universe. The possibility of harnessing the fundamental forces of the universe is undeniably captivating, yet it also comes with its own set of risks. The mini Big Bang is not merely a theoretical concept, it is a real phenomenon happening inside the LHC. The collider creates intense conditions, heat, pressure, and energy, mirroring the very environment at the dawn of the universe. It's as though we are witnessing the birth of time itself. However, such enormous power comes with great responsibility. What if something goes wrong? This concern is not new. In 1978, Russian physicist Anatoly Bugorsky experienced an incident that drastically changed the course of his life. While working with the U-70 synchrotron at the Institute for High-Energy Physics in Protvino, Russia, a malfunction caused a proton beam to inadvertently cross his path. The beam, traveling at an unimaginable speed, pierced his skull, entering from the back and exiting through his nose. Though Bugorsky saw a flash of light brighter than 1,000 suns, he remained conscious and walked to receive medical attention. The aftermath was both fascinating and alarming. He lost hearing in one ear and suffered partial facial paralysis. Despite the severity of the injury, his cognitive abilities remained intact, and he continued his scientific work. Bugorsky's experience serves as a grim reminder of the power and possible dangers posed by particle accelerators. The risks associated with an atom smasher like the LHC should never be taken lightly. Concerns about unforeseen reactions that could alter the very fabric of reality have led some scientists to worry about the possibility of creating a miniature black hole within the collider. Black holes are regions where gravity is so intense that not even light can escape. These destructive forces lurk at the edges of the cosmos. The idea that the LHC could create even a tiny black hole is both awe-inspiring and terrifying. Could such a black hole grow uncontrollably, eventually consuming the Earth from the inside out? CERN researchers have reassured the public that any black hole created would be highly unstable and would vanish almost immediately. Still, the mere possibility of such an event has sparked debate and concern. To understand how the LHC could potentially create a black hole, we must first examine the basic operations of a particle accelerator. When protons collide at nearly the speed of light, the energy produced is so immense that it can distort the very fabric of spacetime itself. Imagine a trampoline stretched tightly with a heavy object dropped onto it. The fabric bends, and if the object is massive enough, it can create a depression so deep that anything nearby would be pulled into it. This analogy offers a glimpse into how the LHC could affect spacetime at a quantum level, where the laws of physics become strange and unpredictable. A theory has been proposed suggesting the existence of extra dimensions beyond our familiar 3 dimensions of space and 1 of time. If these additional dimensions exist, the LHC might have the ability to tap into them, potentially creating a gravitational well that forms a tiny black hole. The possibility of this happening has drawn the attention of renowned physicists, including the late Stephen Hawking. In his writings, Hawking warned that the Higgs boson could become unstable at high energies, possibly triggering catastrophic consequences like vacuum decay. Sir Martin Rees, a distinguished astrophysicist, also raised concerns about the LHC's experiments. In his book on the future of humanity, he explored the potential dangers posed by particle accelerators, acknowledging that while the chances of such an event were low, even a small probability warranted careful consideration. The stakes are high, and the margin for error is razor-thin. Researchers at CERN have conducted extensive simulations and analyses. It's easy to get caught up in sensational headlines and fears of cosmic disasters. The truth, however, is that scientists at CERN are fully aware of the potential risks. They have taken every possible measure to guarantee the safety of their experiments and continuously monitor and assess their work with the highest degree of diligence. The benefits of their research, such as uncovering the secrets of dark matter, discovering new particles, and deepening our comprehension of the universe, are truly remarkable. These breakthroughs represent a significant leap forward in human knowledge, yet they come with inherent risks. Like all great scientific advances, the LHC's experiments pose profound ethical questions. Could the creation of exotic particles or the study of extreme energy conditions trigger unforeseen consequences for our planet or even for the very fabric of reality? These questions cannot be taken lightly and must be carefully considered in the broader context of scientific progress. In conclusion, the Large Hadron Collider is a monumental achievement in human ingenuity and curiosity. It has already led to groundbreaking discoveries in particle physics, shedding light on the universe's fundamental workings. However, as we explore these uncharted territories, we must maintain vigilance and be aware of potential dangers. The search for knowledge is one of humanity's most ambitious endeavors, but it is not without its challenges. The LHC stands at the forefront of scientific exploration, where theory meets experimentation and where the foundations of our understanding of the universe are being tested. The journey of discovery is never without peril, and the LHC is no exception. It pushes the limits of physics, attempting to reconcile the fundamental forces of nature and answer age-old questions about the origins of mass and the nature of dark matter. Yet, as we proceed to investigate these frontiers, we must consider the profound ethical and existential dilemmas that arise from manipulating the forces that govern the universe. The risks of unintended consequences, whether for our planet or for the very fabric of spacetime itself, remain a challenge that demands thoughtful reflection. Nevertheless, the pursuit of knowledge remains one of humanity's most noble endeavors. The LHC's experiments, while risky, offer us a glimpse into vast, unexplored realms of science. As we stand on the verge of discovery, we must approach the journey with both ambition and caution. The LHC represents not only the pinnacle of human technological achievement but also a powerful tool that has the potential to reshape our understanding of everything, from subatomic particles to the grandest cosmic phenomena. With every breakthrough comes a new wave of questions, opening fresh avenues of exploration and thought. The path of scientific discovery is uncertain, but it holds the promise of revelations that could redefine our understanding of the universe, our place in it, and the very rules that govern reality. One of the most profound aspects of the LHC's experiments is the intersection between theory and reality. For decades, physicists have wrestled with the forces that shape the cosmos: gravity, electromagnetism, the weak nuclear force, and the strong nuclear force. The unification of these forces into a single cohesive framework, a theory of everything, has always been the ultimate goal. The LHC has played a crucial role in providing experimental evidence and insights that bring us closer to this elusive objective. Not only does its work advance our understanding of particle physics, but it also holds the key to uncovering fundamental truths about existence itself. The ethical dilemmas associated with these experiments are profound, yet the pursuit of knowledge has always been fraught with risk. When those risks involve modifying the fabric of space and time, the stakes increase dramatically. Could a single experiment at the LHC inadvertently trigger a phenomenon we don't yet understand, leading to consequences that are impossible to predict? This is a question that scientists, philosophers, and ethicists alike continue to explore. As we delve into these uncharted territories, we must bear in mind the responsibility that comes with wielding such immense power. Despite the possibility of danger, very few would argue against the pursuit of scientific progress. The rewards, new technologies, medical breakthroughs, and a deeper understanding of the universe, are immense. The discoveries made by the LHC so far have already transformed the landscape of science, from the identification of the Higgs boson to advances in our understanding of dark matter. These achievements have far-reaching implications, not only for physics but also for other fields that rely on this foundational knowledge. As we continue to push the boundaries of possibility, the LHC serves as a reminder that science is never without uncertainty. No experiment is entirely risk-free, and as powerful as the LHC is, it is no exception. But with every risk comes the potential for monumental discoveries. The LHC is a symbol of humanity's relentless pursuit of knowledge, a quest to answer the questions that have puzzled us for centuries. Ultimately, it is this curiosity that drives us forward, the desire to comprehend the cosmos, to peer into the depths of space and time, and to uncover the forces that govern everything from the tiniest particles to the largest galaxies. This is what fuels scientific progress. The LHC may carry risks, but it also represents the peak of human achievement in particle physics. It is a tool that enables us to explore the most profound questions about existence, challenge the very laws of nature, and seek answers to mysteries that have eluded us for millennia. Whether or not the LHC leads to the discovery of new dimensions, parallel universes, or unforeseen phenomena remains uncertain. What we do know is that it is one of the most powerful instruments ever created, capable of revealing universe-wide secrets that were once thought to be beyond our reach. The potential for discovery is limitless. As we delve further into the unknown, we are reminded that science is a journey, one that requires both daring and responsibility. The experiments at CERN continue, and we must remain mindful of the possibilities, the risks, and the enormous potential for new knowledge that lies ahead. The LHC, while embodying the cutting edge of modern science, is also a reflection of our deeper quest for meaning and comprehension in a vast and mysterious universe. With each new discovery, we move closer to a fuller understanding of the forces that shape our existence. As the LHC continues to push the frontiers of particle physics, the scientific community remains on the cusp of discoveries that could reshape our understanding of reality itself. With ongoing upgrades and new experiments planned, the collider is set to operate at even higher energies, probing deeper into the nature of fundamental forces and particles. One of the most anticipated areas of research is the search for physics beyond the standard model. While the discovery of the Higgs boson was a monumental achievement, many physicists believe that it is just one piece of a much larger puzzle. Dark matter, dark energy, and the unification of quantum mechanics with general relativity remain some of the greatest mysteries in science. The LHC's experiments, such as those conducted at the ATLAS and CMS detectors, are designed to uncover potential new particles that could explain these unresolved questions. Moreover, the prospect of discovering extra dimensions remains a tantalizing possibility. Some theoretical frameworks, like string theory, propose that additional spatial dimensions exist beyond the three we perceive. If the LHC were to provide evidence for these dimensions, it would revolutionize our understanding of space, time, and gravity itself. Yet, as we peer deeper into the subatomic world, new challenges emerge, not just scientific, but philosophical and ethical as well. If the universe operates under principles that defy our current understanding, what responsibilities do we have in exploring them? Could we inadvertently create phenomena with consequences beyond our comprehension? While fears of black holes or catastrophic vacuum decay are largely unfounded based on current physics, the ethical responsibility of wielding such power must always be considered. Beyond theoretical discoveries, the LHC's contributions to practical technology cannot be overstated. The massive computing power required to process its data has led to advancements in artificial intelligence, machine learning, and high-performance computing. Medical imaging, cancer treatments, and materials science have all benefited from research conducted at CERN. The World Wide Web itself, originally developed at CERN to facilitate scientific collaboration, is a testament to how fundamental research can transform everyday life. As humanity stands on the precipice of a new era in physics, the lessons learned from the LHC will shape future projects, such as the proposed Future Circular Collider, FCC. This next-generation machine would dwarf the LHC, reaching even higher energies and allowing us to probe deeper into the fundamental nature of reality. Whether or not it becomes a reality, the LHC has already cemented its place in history as one of the most ambitious scientific endeavors ever undertaken. In the end, the pursuit of knowledge is both a privilege and a responsibility. The LHC represents the best of human curiosity, ambition, and ingenuity. While risks and uncertainties remain, the rewards, greater understanding, technological advancements, and perhaps even a glimpse into the very fabric of existence, are what drive us forward. As the experiments continue, one thing is certain: the quest for knowledge will never cease, and the mysteries of the universe will continue to inspire generations to come.